Welcome back to section 6.2, page 4. So we've got a couple of theorems here to look at. It says if an angle is formed by a secant, okay, so let's draw the secant, and a tangent, well, we got to know the rest of it, that intersect in the exterior of the circle. So here's the exterior, okay, and then we're drawing a secant. Now remember, a secant touches the circle in two places, so let's go ahead and draw a secant. Okay, so it touches here and here, whereas the tangent only touches one. So let's draw the tangent here. Okay, so let's call this A, B, C, and D. So what does it tell us? It tells us then the measure of the angle, so this angle C, ooh, I called it L here. We'll just change this to C here. The textbook must call it L. Okay, so the measure of angle C then, what is it equal to? 1/2 the difference of the measures of its intercepted arcs. Well, we know that. Where is the vertex? Vertex is outside circle. Vertex is outside the circle. So that means you take the difference of the intercepted arcs. So let's take the big one here, AD, measure of arc AD, and then subtract from it the smaller intercepted arc. So this is BD. Okay, and that's the formula there. So let's try here. If an angle is formed by two intersecting tangents, okay, so we just want the tangent. So here's our outside, and we're going to touch here just in one spot, okay, and same thing here. Okay, so about there. So we call this A, B, C, and then we're going to need a point over here just to distinguish between what we mean. Oh, this one turned out right. So the measure of angle B, what does it say? The measure of the angle is 1/2. I don't even think we need to read the theorem. It says the difference of the measures of the intercepted arcs, but look again. Where is the vertex? Vertex is outside circle. So we have all these theorems, but really it's the same thing over and over. Okay, so the measure of the intercepted arcs. So which one are we talking about? Well, we've got this big one here that we're talking about, and then we're talking about this small one here. Okay, so we have the measure of this arc here, which is going to be ADC, minus this arc here, which is AC. Okay, so let's try a problem using this information. So number 8 says that AB and AC, those two rays, are tangent. You can see they touch at 2 points. And the measure of arc BC, so BC, so that goes from B to C, that's the arc there, is 126 degrees. So let's do that. Okay, so that arc is 126 degrees. Okay, then let's go ahead and talk about the measure of angle A. Well, angle A, where is its vertex? So part A. Can you see all that? Okay, so angle A has vertex outside circle. Okay, so what is the formula? Well, when it's outside the circle, you subtract. So the measure of angle A is equal to 1/2, and then subtract the two arcs. So here it is. The big arc would be this one. Okay, so arc CDB. And then we're going to subtract the smaller arc, BC. Okay, so what do we know here? Well, we know the measure of arc BC, but then do we also know this bigger one? What do we know about all the way around the circle? all the way around the circle has to be 360. So if we say 360, let's do it over here, 360 degrees minus 126, what do we get there? 4, 3, 2, 234. Isn't that what the other piece has to be? Let me grab this here, mark it. All the way around has to be, okay, it has to be 234. I mean, it has to be 360. So this part has to be 234 here. Okay, so let's put that in. This one measures 234. We're subtracting BC, which is 126. So what does that give us? Well, 1/2 of whatever that is. So let's see, 234 minus 126, I get 108. Okay, and half of that would equal 54. Okay, so we have 54 degrees for the measure of angle A. Now we're asked for the measure of angle ABC. So let's locate that. ABC. You're now talking about this angle here. Okay, where is its vertex? Its vertex is on the circle, so a different formula. So angle ABC has vertex on the circle. Okay, so these are the critical words. So when it's on, what's our formula for on? It's inscribed. We say it's 1/2 the measure of the intercepted arc. So what's the intercepted arc? Well, here's our angle right here. Remember, it's ABC, so it's this angle right here. So its intercepted arc would go from this piece of this ray of the angle right here all the way to that ray. So it's just BC. Okay, so the measure of angle ABC is equal to 1/2 what? Well, that arc measures 126. So half of that would be 63 degrees. Okay, and now part C, the measure of angle ACB. So ACB, where's the vertex for that angle? It's on the circle. So angle ACB has vertex on the circle. So what's the formula? The measure of angle ACB, since it's on the circle, it's 1/2 the measure of its intercepted arc. So what's its intercepted arc? Well, let's look at it again. ACB. So this ray, we start here. We're going to go here, and then we go all the way to the other end of the angle. So it's BC again. So the measure of angle ACB is equal to 1/2 what? Same thing, 126. And what do we get there? 63 degrees. Okay, so how would we be able to check this? Well, if we take a look here, we can see that we have formed a triangle here. And we just found all the measures of the angles. We found that measure A right here is 54. We found that ABC, so this one here is 63. And we found this one here, which is ACB, is 63. So if we wanted to check, we could add all those up. 54 plus 63 plus 63. And since it's a triangle, what should it equal? Well, let's see. We get 0, 1, 7, and 12. Something worked wrong there. 6 and 12 is, can't add. That's what worked wrong. 180 degrees. That's a check because these are the angles of the triangle. Angles of a triangle. So it should be 180. So that's a good check. All right, so on to our last theorem on this page. It says, if two parallel lines intersect a circle, the intercepted arcs between these lines are congruent. Well, that should make sense to us. Here we have parallel lines. Remember, parallel lines are equidistant everywhere. So if they're equidistant everywhere, these arcs should be the same as well. So we're going to say, in fact, I mean, you could even, well, we won't get into that, but let's write the statement. If the lines are parallel, so if AB is parallel to CD, those two lines are parallel, then what can we say? We say their arcs are congruent. So here's the arc. AC is congruent to BD. And we're done with page 4.